sorry. Sorry guys, I was muted. My bad. Okay, there it is. There it is. I'm back on. Can y'all hear me? Okay, that's life. And as you know it, let's go. He's in the chat. All right, guys. How's my audio now? And thank you for that. I forgot to unmute myself. All right. Yeah, guys. Can't hear you. How about now, Mary? How about now? Let me just check this. That's life. And as you know. Okay, it is. Go. Okay, it's working. Okay. Let me know, guys, how the audio is good. Is it too high? Is it clipping? Etc. Etc. I'm gonna open up this pop-out chat. Okay, all good now. Okay, epic stuff. Yeah, I had it muted the whole time for some reason by accident because there's a button I need to press on my microphone. Okay, so this is this thing. Whoops, why didn't it just do that? Okay, this is the worst. Okay, so it's like copy. I'm gonna paste the chat right here. So what I'm gonna do, a new strategy. I'm gonna keep the other alternative chats. I only have Rumble and Odyssey. Didn't have time to set the other ones. Yeah, epic stuff. Let's go. Mary Kilbane and William. That's life, but not as you know it. Let's go, guys. We have 5 people in this show. Today's gonna be quite interesting. We'll go over a bunch of random stuff. But I do want to focus on that magnetic mirror. First time I came across it a few days ago when I was doing my math video, and I'm like, what in the world is going on here? But also we'll go with some other stuff. I do want to look at some of the MH370 stuff that Ashton Forbes is constantly doing nonsense about. Live in 9 months. Oh, this is different. Why is it showing up this thingy? Okay, that's a different thingy there. Okay, Rotary Matrix in the show. Let's go. Okay, I just want to check this thingy. I thought there's a live button. Okay, where's my live button? Okay, I'm gonna open up my Rumble. Anyways, I mean just housekeeping quickly, trying to figure out some stuff. Okay, let's go. Click this thingy. Click here. Okay, just click the Odyssey. I just want to open up the chat. Okay, Rotary Matrix in the house. Yeah, Rotary Matrix. Ashton Forbes is going wild today, or this past week. I still to this day do not understand what in the world's going on with Ashton. How do people still take him seriously? He's talking about wormholes and teleportation of when all he's showing for it is the 2 cartoons. All right. Okay. Why didn't I just hate this stuff now? Copy. Okay, so I'm gonna paste this. It still will not allow me to copy. Okay, there's Odyssey chat. Yeah, there it is. Okay, so now a new setup. I'm just gonna keep the alternative chats right here. Okay, it says I'm offline. I have no idea what's going on here. I probably set up something anyway. So it says I'm offline. I think I might have messed it up somehow. 1 second. Almost gonna set it up. I'm gonna click Odyssey. One more chance. I think I said the wrong date. Magnetic mirror. When is it live? Okay, reset stream. Released 6 minutes ago. It should reset. Okay, so it should work starting soon. Okay, so anyways, if it doesn't work, the other ones are working. Rumble's working. Okay, I'm gonna say, can y'all hear me in here? That's just running scared, doing damage control and backtracking all over the place. Yeah, it's weird. He says it's not the satellite. It's actually some Gorgon stare, and then all of a sudden he's going over some the heat signature on the plane. I'm like, what in the world's going on here? Okay, and I'm also trying to help John Hutchison figure some stuff out with his Facebook. He got logged out again. He doesn't know how to log back in, and I'm trying to help him out. Anyways, okay, so I'm gonna jump right into see what the math Q&A is, because again, if you have any questions and so on, I'm gonna just open up some stuff here. This is math. I'm gonna close some stuff to make it simpler. Oh yeah, so before we get further, okay, so I got tagged by this Baker Tuts guy who's a MH70 debunker. He tagged me on the airline abduction 2014. This is like the biggest one in Discord about the MH370, and then so he tagged me, and then then I went and replied. Well, he sent this thing. He's saying that the portal thing is just stock footage, right? And then I replied in this, and it's a pretty big group. How do I even check how big it is? Discord, I get brain damage looking at Discord because I'm like, there's so many thingies. Like, what am I looking at? Like, what do I do? What is this? Where is? Okay, there's a question mark. No. How many people are in the Discord? How do I check this and all this? Just want to see browse channels. Browse channels. No. Okay. How big is this? There's nothing you could chat. App directory. Okay. So anyways. I have no idea, but it's pretty big. So in the general chat, I replied to him, and then I said, and I kind of created mayhem right here. So I said, you need a PhD in butt physics to properly analyze the video. So So let's ask Professor Ashton what he thinks about all this. We'll play this.
Fake an event, they would fake it as an explosion because there's no basis to even think to create this. Somebody that would have to fake this is going to have to understand physics better than most PhDs out there. In order to create the pattern that we saw, they're going to have to understand math better than most PhD math experts as well. So this requires a huge amount of creativity if they were going to create this. There's no basis to copy this from. So what we see here is this endothermic event that's absorbing energy. We've speculated that this is potentially sucking the energy out of these lithium-ion batteries so that you can actually save this plane.
Let's see how he proves that it's not stock footage.
So as a statement of fact, those do not match.
Dude, it is exact.
Thank you.
Thank you, Danny.
It's not though. You see that the black actually does not line up, right? You see how it's not the same on the the edges? All dispersal patterns look the same.
Did you know that? All dispersal patterns look the
Wait,
same?
all dispersion? No.
This is like saying that my butthole is your butthole because they're similar.
What? Okay, that's wild. To think, like, when you want to be taken seriously, that's what you go.
Somebody that would have to fake this is going to have to understand physics better than most PhDs out there. In order to create the pattern that we saw, they're going to have to understand math better than most PhD math experts as well. This is like saying that my butthole is your butthole because they're similar. This is like saying
somebody
that
would have to
is your
fake this
butthole
is going to have to
because they're
understand
similar.
physics better
This is
than
like
most
saying that my
PhDs
butthole
out
is
there.
your butthole because they're
In
similar.
order to create the pattern
This is
that
like
we
saying
saw,
that
they're going to
my
have to
butthole is
understand
your
math
butthole because
better
they're
than most
similar.
PhD math
This is like saying that
experts
my
as well.
butthole is your butthole because they're similar.
All right. Anyways, so how is he still going viral every chance he gets? And then anyways, I'm gonna roast Ashton a bit more. So I got tagged by a French KJ French 911 guy, and I can't even reply to him, so I had to quote post it. So it says here, it says the IT guy. Okay. So right here, so there's a KJ French guy. He says this guy was saying that, oh, this is pretty big. He's replying to him in French. So apparently the French people are getting yeah, they're trying to tag magazine Nexus. Holy, they're trying to get this French channel talking about this Ashton nonsense again. And then KJ French guy replies to him, says, okay, first this guy says here, this case could be interesting dealing with as much or even more than 9/11. My goodness, no, are you nuts? This guy says, and then he says, non c'est bien le 11 neuf, how do you say 11? Qui permet de... But anyways, I might do a translation dubbing over the Ashton Forbes in French. So it says, no, it is indeed 9/11 that allows us to decipher the rest, including the quote UFOs. But Ashton won't say anything about 9/11. He's been exposed by several people. And then I tagged, but I can't even reply. So if I click reply, I can't because Ashton blocked me. So even on the replies of other people, I can't even reply. So then I quote posted him and said this. I used the extra translator. I said, qui le professeur Ashton, docteur en physique de physics. Éviter le 11 septembre parce qu'elle est occupée à profiter des dizaines animés bidons et des extraterrestrials de Miami. Ashton fake orbs. Alright. And then it basically translates, yeah, Professor Ashton, doctor of butt physics, avoids 9/11 because he's busy enjoying lame cartoons and aliens from Miami. I actually wanted to say fake cartoon, like basically grifting off fake cartoons. But anyways, let's play this one here.
And then there was this letter to Ashton Forbes on YouTube. You guys can check it out yourself. I promise you I did not write this letter. It's the weirdest thing that's ever happened in my whole life. It's called Diego Garcia Whistleblower, Letter to Ashton Forbes. It came out in early January, several days after I was on Tim Pool's Culture Wars podcast.
This is a submission sent to us the 8th of January of 2024. It's a letter to an Ashton Forbes telling a new story of what happened to Malaysian Airlines MH370 that disappeared back in 2014. And as always, don't trust what you read on the news. Trust your own capability to see the world for what it really is. Here we go.
I work or have worked at a military base in the Maldives, and I know exactly what happened to Malaysian Airlines MH370. This is also a letter to Ashton Forbes. You are not wrong, and what you do are much bigger than you even can imagine. Don't stop what you are doing. I won't tell anything about myself more than that I currently or in the past has spent time at a military base in the Maldives. I encourage you to keep on with what you are doing, but you should also be aware that there is a deeper layer that you could focus on instead of the Miami aliens that I see you have been posting about.
Go back to Miami aliens. He actually got 11 million. He said he got 11 million views on that post. He said it's his most viewed post ever, and it's just a bunch of nonsense. Apparently, there was some witnesses reporting 8 to 10 foot shadow beings were being shot at. So in other words, shadows. All right. Anyways.
Then in 2014, military footage of the event got published on YouTube. Not our problem. The person responsible for the leak was identified and taken care of. Not by us. Not our problem. Then came you. Hi, Ashton. Impressive.
Promise you I did not write this letter.
Finally, I want to say this. How do you defeat someone who can turn skyscrapers to dust, completely erase whole neighborhoods in an afternoon and...
Yeah, there it is. And then he tried to say that you could teleport planes and so on. But anyways, so he says I avoid 9/11, but dues are absolutely real and so on. So again, just runs and hides while he writes letters to himself. Okay, Timmy Stubble's in house. Let's go. All right, guys. So today, if you guys have any math Q&A, I'm gonna. There's that one person that always asks me in this chat here. Let's see if I find it. Okay. I'll send a link to the stream. How do I open up the stream? So it's like, all right. It's just impossible. Cashed in fake news. Yeah. Okay. I'll send this right here. Man, this is impossible to just get links to stuff. Okay, there it is. Doing a live stream now if you want to ask specific questions. Okay. Yeah, if there's any on there. Oh yeah, so Dr. Bas Akbord says, so what's your opinion on what's going on with this grift and of this? Why is everyone so duped by his garbage? I think it's twofold. One, it's like a giant social experiment to see how if people can believe something if you keep repeating it enough. But also, it's I think it's Project Bluebeam, like predictive programming. Slash everybody get used to, oh, there's teleportation, UFOs, and so on. But at the same time, he make it so stupid that it doesn't get anywhere, so that it's still under government wraps. Basically, anyways, a bunch of, but I think it's main one social experiment. But here's also, I made a meme right here. It's a new Ashton Forbes meme alert. Never give up on your dream, even if it is complete nonsense. So basically, it's that setup. If you keep telling something nonstop, if you keep pushing for your dream. So anyways, talk nonstop nonsense, and you'll get on the Jimmy Dore Show, Candace Owens, Benny Johnson, Redacted, Tim Pool, Glenn Beck, Sean Edwards, The Lodge, The Y-Files, The Sean Farash Project, Blurry Creatures, Sean D'Souza, Emerald Robinson, Richard Cirati, Lindell TV, Jeremy Ryan, Slate, Kim Iverson. All right, yeah, it's a misdirection, but also a social experiment. And it's also a way to loop all the alt media and like easily discredit. It's kind of like saying, it's like the David Icke strategy. It's kind of like, oh, David Icke says 9/11 is an inside job. Oh, but also, he also thinks that the Queen is a lizard. It's like, what? It's like, what? Even if she is a lizard. So like, and then, but anyways, I asked Grok to make a list of all this stuff. But again, going on Jimmy Dore Show, but also you'll see who's a grifter and who's, again, just gullible. Like, and the only reason, again, you have to realize, the only reason I covered this is similar with the moon landing, is because is Andrew Johnson initially, yeah, he thought that this could be real, this MH370 teleporting, or Ashton Forbes could be a real guy. So it's like basically because I learned about 9/11 from Andrew Johnson, I owe it to him to help him keep on the right track as well. So it's like he got me on the right track 9/11. I'm trying to help him get on the right track of this MH370. I looked at it strictly because he covered it, and then otherwise I would have ignored it. And then good thing I covered it because I didn't realize how big it was gonna get. Yeah, so it's hard to take channel serious after seeing Ashton on the show. I can't even ever watch Redacted again. And yeah, definitely, it's similar to Jimmy Dore. It's like, well, he gets that out now. It's like, okay, what other part is he lying about? Like, or just like nonsense about? Like, how could you How can you get this guy on the show? Talking about like 2 cartoons. It's like this is just it's just absurd. But again, Ashton's like a professional liar. He's actually and he's pretty funny. It's like the way he it's like you can tell from his smirk, like this smirk right here. Like this guy right here. this guy is a maverick scientist. Yeah, it's just so funny though. Like I don't know how he's but I think this one's real. So I posted this before. This was Ashton Forbes update. Ashton Forbes and like apparently this is, I'm not sure how true it is, but it's plausible. Isn't Candace Owen minimum 50K to get on? Well, yeah, that's if you want like if you want her on, but she probably got him on for free because it's all part of the same grift network. So I call it the Disinformation Industrial Complex, DIC for short. So they're all a dick member. So anyways, this one here, Ashton Forbes, Aunt Mary is worried Ashton stopped taking his meds, and then this comment appears to be deleted now, and that account was created on June 15th, 2024. So it was created recently last year, and then they posted a comment, but a follow-up comment suggested it is really his aunt. Hope Ashton gets the help he needs. Hashtag pray for Ashton. Update, the follow-up comment is removed as well. I think I archived it, but Inter Archive is currently down. Yeah, down due to a hijacker. So I'll check up the follow-up comment because I think he's back on. Okay, so if you check your 29,000 tons of thermite. So if you go right here. Okay, so this person, I saw it and I took the screenshot. No, I think someone took a screenshot. I didn't take it, but someone took a screenshot of this, and then I looked. It appeared to be deleted. So this one, Ashton, please start taking your meds again. Aunt Murray has been calling you, and she says you haven't answered. We were all worried about you, and then I was checking. Yeah, so basically this is a real account. It looks like they deleted the comment, but then I saw this one and I archived it. So Ashton, I urge you to please listen to Julie. From what I can tell after following up on your quote story, I can say with confidence that you need help. I urge you to get in touch with your family and seek treatment. We're all concerned for you, Ashton. This is no longer a game or funny. I take no pleasure in watching someone suffer from mental illness or struggle with mental health. Shame on these disgusting trolls that encourage you and enable you further. Please, Ashton, take a break from the internet for a while, and with all due respect, reach out to a medical professional. All right, so that's that. Anyways, if you guys have questions on Math Q&A, this is your 2 hours of you can ask me stuff, and I will. I'm gonna go over the magnetic mirror stuff. That's pretty interesting. This should be there. A follow-up comment. I think I did archive it. I'm pretty sure. Yeah, I'm pretty sure I archived this one. Just see that. Okay, search that. Okay, so it's not there. But anyways, I did see that one. Anyway, so that was me searching it, so you can take my word. But anyways, so I asked Grok to put all the, make a table of all the channels and so on, and how many subscribers they had. So, showing subscriber notes, I included, let's see some other ones. So he was on the, Ashton Forbes' own channel is 125K subscribers. The Lower Lodge, 300,000. This one, Y-Files, 3.1 million. Redacted, 2.7 million. And then Jimmy Dore, 1.5 million. So again, it's like, how do you get on this? And then Candace Owens as well. And it's like and it's not easy to like, it's not easy to get on these shows. And then so they need to like prepare everything for it, especially when he visited actually Candace Owens and did a live with her, like actually recording with her, and so on. 1 second, getting some messages. Close this. Yeah, so that's that. But anyways, so it's like, especially the Candace Owens one. So I'll go to Candace Owens. And then Candace Owens. How do you spell Candace Owens? Call it Candace Owens. There it is. Candace. Okay, and there's, anyways, there's Candace Owens and Charlie Kirk doing the Illuminati hand sign. Are there any other events where you think 9/11 tech was used? Yeah, I think Oklahoma City bombing was 9/11 tech, but I think a lot of stuff, like even small ones, they might do it just because it's probably easier than actually setting up an explosive, even if it's like a. Yeah, so I'm just saying that there could be a lot of other ones, but the one that comes to mind is the yeah. So this one here. I'm gonna go to Candace Owens. I think I could have sworn. Okay, Ashton. 2014. He saw it. Yeah, this one right here. So Ashton admits so imagine this setup with I'm gonna click the whole full video.
Same time the plane.
So like imagine that like he has to go there, fly to Candace Owens, and then sit down and then have a whole producer crew and like background research gang researching this guy to make sure that everything's legit. And it's like they give the A-OK. So in other words, the entire team that's behind Candace Owens, they have to be part of this grift. This is just a straight up grift. There's this and straight up disinfo. So it's like you can tell they're part of the same clique. Because it's like there's not a chance anyone can go in and look at Ashton Forbes' claims and come back as saying he's a sane person. So anyways, so that's that. I'm going to go see if anyone else has stuff. I'm going to go over the reason I put a magnetic mirror stuff. And also there's, for those who haven't seen, Rich Planet, I messaged him trying to collaborate with him. So this is, I'm going to open this up. I'm going to go and keep this up open. So now I'm going to go into the video I made. So I made a 5-hour video again. This one took me. I'm trying to get more focus and stick on the video one. So I'll try to get the 9/11 exterior lobby columns video up. I'll try to power through that. So again, this was 5 hours. The math ones. When I don't do a math video, again, like I was saying, I feel dumb. I feel like getting dumber if I just don't do it. So this one here, to do a 5-hour video with all the notes here and everything, it's not easy. But the thing is, it's like you're able to structure your mind. And anyways, and I put the notes here. This is what I wanted to cover, the magnetic mirror. So, and the reason, in the video, I went over some magnetic stuff in here. So magnetic mirror reflection, magnetic mirror. So this is an electron beam, and there's apparently a magnetic mirror, and it's like reflecting off. So there's an electron beam and a magnetic field, but then there's like a magnetic mirror. So this thing, I need to learn what in the world this is. So multiple reflections of an oblique electron beam in a mirror magnetic field. What in the world is going on here? They used it in DC too last year when McCloskey visited too. Interesting. Okay, magnetic mirror. I need to learn what a magnetic mirror is. So this is it just seems so interesting. So magnetic mirror, also known as a magnetic trap or sometimes as a pyrotron, is a type of magnetic confinement fusion device used in fusion power to trap high temperature plasma using magnetic fields. I think they might have used similar to destroy Jordan Guidestones. Possible. Well, the thing is, it's like let's say they did a super lightweight one where it's like you could even fake a firecracker. So it's like, but instead of actually having to go and install a firecracker, it might go off, might not. You just literally just send a little dew from anywhere. So it's like a lot of stuff you could do that. Yeah, it's kind of like. The internet. You can watch videos. You can send a text. You could do audio. You could send a lot of other types of information. So when you have that kind of technology with do, now you could do a whole bunch of stuff. you can blow up building. You can turn it to dust. You can probably superheat it as well. You can probably super cold it. You could take all the energy out. You can shake it. You can do a lot of stuff at a distance. So the key thing is motion at a distance, like physical thing at a distance. And then what's interesting. That's pretty much what magic is, according to Aleister Crowley. It's like your will at a distance. So it's like pretty much do. Okay, and then, anyway, so magnetic mirror. I need to learn what this is. Also known as a magnetic trap, or sometimes a pyrotron, is a type of magnetic field used to trap high temperature plasma using magnetic fields. The mirror was one of the earliest approaches to fusion power, along with the Stellator and Z-pinch machines. Yeah, crop circles do. Yeah, in a classic magnetic mirror, a configuration of electromagnets is used to create an area with an increasing density of magnetic field lines at either end of a confinement volume. Particles approaching the ends experience an increasing force that will eventually causes them to reverse direction and return to the confinement area. So particles approaching the ends experience an increasing force that eventually causes them to reverse direction. Okay, so basically, it's in a classical one, it's configuration of electromagnets used to create an area, increased density of magnetic fields at either end. So basically, at the ends are extreme density of magnetic fields, so basically stronger. So then that if a particle goes there, it gets repelled, goes back into the center. Causes them to reverse direction and return to the confinement area. This mirror effect will occur only for particles within a limited range of velocities and angles of approach, while those outside limits will escape, making mirrors inherently leaky. Okay. There's a boom. All the live streams went down. No phone signals. All sounds like a small boom. Interesting. All right. So this is magnetic field setup. And the one thing again about the magnetic fields, I think why it's hard for a lot of people to grasp, including me, is because this magnetic field, they use the flux lines. If they just use those donut shaped, not donut shaped, the blob shaped isopotential lines. Like I sent an email to Richard Hall, it helps understanding everything. So anyways, so particle motion. This is the current. So basically, yeah, the current goes in a circle. So you so basically it's super strong here. Okay, that makes sense. So basically, remember, everything is ether. So this is, think of this as a super strong vortex. And this is weak vortex. So then the particle is like pretty much forced to go over here. That doesn't want to go into this like vortex area. So it goes into this little pool there. Alright, so that's that. Okay, this mirror effect will only occur for particles with a limited... Okay, I do want to see some other info on it. This is magnetic mirror. Okay, so that's what it is. I think I pretty much understand it now. So I'm going to go over... Holy, look at this. $372 million Livermore project that was mothballed. What in the world is mothballed, Neil? It's okay. They stopped work, but they can work on it later. Okay, so it's like you give me 372 million. So there's another thing about the cold fusion stuff and like alternative science that a lot of people don't grasp is that the mainstream science has millions, billions, and trillions of dollars put into it. So like this is all put into this one. But imagine all this kind of tech was put into, let's say, anti-gravity or cold fusion, as opposed to just a little magnetic field stuff that we all know about. Hall's posted results of his hollow generator investigation in 2 videos. It's fascinating. Yeah, I saw this first one. I didn't see the results. I will have a look at it later. Again, and I gave him some ideas to tinker with. So anyways, I'm gonna go over magnetic mirror and then see some experiments on it. Because I'm an experiment. Oh, there's me. First thing shows up is me. Let's go. And I like these keywords. Magnetic mirror. You need one of these. So what is it? This guy's take selfies with this magnetic mirror. Selfies with magnetic mirror.
If you want to take better selfies with your phone, then you might want to...
this is a magnetic mirror. I want to say... Everything's just an actual magnetic mirror. Just a magnet of the mirror. I don't want that. Magnetic mirror... Confinement. Gotta go for a few. BRB. Let's go, Mary. Okay, have a good one. And yeah, definitely check out the Richard Hall stuff. So there's the Richard Hall stuff, guys. Richard Hall's on another level. He's... What's interesting is like me and Richard Hall. I kind of feel like we're the same person, but from like a different like what's that called? Lifetime. We're the same person at a different time. It's like and even the end machine. Like I literally have a video saying that the first experiment I want to create is the end machine, first replication one. But again, he has an electrical engineering background, and me is I have an engineering, my civil engineering background, again, that's just schooling. But I have doing the math videos, this is probably the biggest one. It's like being able to do this, I don't care what the subject is. You do a 5-hour video on something that can replace an entire course. You are entitled to do whatever you want. So basically, and here's to give you an idea of that. So this guy here, replied to one of my videos. He says, man, I'm in IT Madras. What is that? And I'm very upset by professors by using X and Y intercepts as points to prove distance formula of point to line. But here we see random point with random point of line. Yeah, so there it is. So this is an example of where you're not going to learn this stuff from it. But also a lot of people, their entire course is just like... I get a lot of messages saying that their entire course is like literally contained in one video, because again, this entire thing is a section of one chapter in a calculus book, and in one chapter in one section would take probably like several weeks of if you go to university you probably have to take like 2 to 3 weeks of like just to cover the one section, or like even a month. So this would be, let's say, 1 month at minimum. So 1 month minimum, you can compress that into this 5 hours, and now you're good to go. Anyways, I'm gonna go back to the confinement stuff. So now we're going back near confinement. Confinement concepts. Magnetic mirror. Okay, Gary Jackson, I enjoy the math even more now that I retired. Yeah, sounds good. Yeah, again, like I was saying, math. The reason I do this is twofold. It helps me. It's like a brain workout, but also it's like helps you to focus and force yourself to structure your thoughts in a way that's reproducible and also referenceable. Like you can reference what you did before, as opposed to like trying to remember everything all at once. All right, this guy replied to my video, I think. I really started to feel like math is a complete visual art, not just symbols and equations. Yeah, definitely. Okay, and now let's go back into this. Also, yeah, I put a link to the Richard Hall stuff. I'll show you the email I sent him. So here's magnetic confinement. I'm trying to learn this stuff.
Magnetic fields can be used to confine electric charges in motion to certain regions of space through two primary mechanisms. First, magnetic charges tend to spiral around magnetic field lines.
Yeah, I'm just gonna increase my desk and then I'm gonna start standing now. Let's do it again. So again, remember this Saturday, this Wednesday streams. These Wednesday streams are basically math Q&A, technical science stuff. If you have any questions, ask me. Otherwise, I will go and try to learn and basically research live on the go for 2 hours. And then also I'll go over some more of the MH370 stuff that Ashton Forbes is going through. Because again, the guy is pretty funny. But nonetheless, we should all capitalize on his grift. He can't be the only one capitalizing on his grift. Let's play this. Actually, wait, I think someone... I kept this open to see what other people say. Okay, that's what makes a cult... Okay, yeah, so that's what makes a cult so scary, especially how they ignore even math. Yeah, so again, this is a giant social experiment. Okay, nobody said anything bad about this video. Again, when you see this video, I tagged Jimmy Dore in it as well. It's like, you just see that you need to, like, delete your video. And actually, before we get to the confinement stuff, going further on the Ashton Forbes, germ warfare. So warfare, oh yeah, I forgot. Germ warfare actually had Ashton Forbes on, and then he got bombarded with people saying it's fake. But then he also retracted it. So germ warfare, Ashton. So again, this is what I mean by you can tell if someone's disingenuous or at least, but then you can also tell if someone's at least trying. So right here. So yeah, so germ warfare. This is the big South African. He's like the South African Joe Rogan. He says, about to record a podcast with Ashton Forbes about the unbelievably strange MH370 flight that went missing in 2014. Was it a wormhole? If you want early access, etc. But now apparently I think he deleted this tweet. Okay, no. So now messages. So he deleted the message. And then germ warfare deleted the interview with disinfo agent and liar Ashton Forbes, and Ashton deletes his own tweet admitting the MH370 videos were fake. Oh yeah, so I even tracked that in live time. Okay, so this was deleted by he replied to Ashton Forbes when Ashton Forbes said he admits that they're fake. Then he says, "Do I put your podcast on ice, take it down, or leave it?" And then and now if you go to the page, he actually deleted the stuff. So again, this is how you can tell if someone is at least trying. So the worst is having a full-on disinfo agent or grifter. So again, so this was deleted by Ashton, and you go here, and then he deleted. So they deleted all ties. They cut all ties with Ashton Forbes. That's good. So basically, and again, I used to watch a bit of Jimmy Dore. Well, I still do it for like intelligence gathering, but obviously he's controlled. But like for intelligence gathering, but then him having Ashton Forbes on is like this complete and utter nonsense. So I've tagged him several times. So if I go here, okay, if I go to from Jimmy Dore, so it's like I've tagged him on several times. So like I literally tagged Ashton Forbes and Ashton, Ashton Forbes, Joe, the guy who created the videos, which I actually think he did. Yeah, so I'm pretty sure he did. And then there's Jimmy Dore, and Jimmy Dore never replied at all, and there's other people tagging and so on. So again, he is so when you watch this butt physics video, it's like, how could you keep him on your channel and then like talking about wormholes and all that? Anyways, go back to this magnetic field confinement, and we'll see what happens.
Magnetic fields can be used to confine electric charges in motion to certain regions of space through two primary mechanisms. First, magnetic charges tend to spiral around magnetic field lines, and the net travel of the charge tends to be along those field lines. Second, in a region where magnetic field lines are converging, there will be a component of magnetic force away from that region. This produces an effective magnetic mirror, which sends the charges spiraling back from whence they came.
All right. Okay. So that's what it is. Okay. I should have included this in the video.
A simple magnetic bottle can be produced by two magnetic dipoles, shown here as two coils. Electric charges can be trapped in the region between these two coils.
What did I miss, Mary? Not much. I was just I was saying why Jimmy Dore was. How is Jimmy Dore not deleting his interview with Ashton Forbes? Because German Warfare deleted their interview.
A toroidal magnetic field can also trap charges by keeping the charges spiraling around the magnetic field lines. This is a simplified version of confinement used in plasma and nuclear fusion research projects like the International Thermonuclear Experimental Reactor.
Okay, yeah, I think I grasp, at least from the mainstream side. Okay, so basically they spiral around and you can trap them in a circle. This is like the Earth's ionosphere. Where you can see the northern lights. There it is.
The Earth's dipole magnetic field can also provide a magnetic trap for electric charge. The charges spiral around the magnetic field lines, traveling north and south. The convergence of the magnetic field lines at the poles serves as magnetic mirrors. The net result is that the charges tend to be trapped in a band around the Earth, forming the Van Allen radiation belts.
Oh, so yes, basically that's Van Allen radiation belt. Okay, that's what it is. It's a bunch of particles, and then this follows a right-hand rule. Let's go back here. Rich Planet is so good. Yeah, I will show you the email I messaged him. So I'm trying to get in contact with him. He replied to me saying he'll review it, and so on. So going back to magnetic mirror stuff, this is very interesting. So basically, the whole idea is, according to mainstream physics, again, they don't actually know the reason. They just follow rules. So if you use right-hand rule, if you have a magnetic field going this way, and this is basically magnetic flux lines going this way, and then if you have your pointer as the charge is going, this is for positive charge. So you have positive charge going like this, and then it will experience a force like that. So then if you have here's a simple calculator. I think I posted it right here. So here's a simple calculator. This is this is a charged particle inside a. So if you draw a magnetic field, let's say this is the flux lines going straight, and then if you have a particle going straight, now it's going to go in a circle. Yeah, but it's going circle but up. Okay, why is it up? Okay, so I think that's how it is. It goes in a circle, but what is the parameter there? I just want to show the magnetic field. Okay, what is it graphing on? So basically it goes in a loop like that. So apparently that's, but okay, what is the, this is the Z velocity. Okay, 0. So yeah, that's the thing. If it had no velocity vertical, it would just go in a circle. So basically a charged particle goes in a circle on a magnetic field. A flux line, that's a flux line. And the key thing, it's like I got to wrap my head around the stuff about the flux line. Actually, yeah, before that, yeah. So basically, that's what happens. And then magnetic mirror just have stronger ones elsewhere. So depending on the speed. But now, if it has a forward velocity, it's gonna go up like that. So there's a forward velocity, and there's the magnetic field flux lines. So flux lines basically the direction where a magnet would go. So like, if you have a magnet going to another magnet, it's basically following that. But what I wanted to illustrate now, because we're talking about a rich planet. So that's what I haven't seen this video yet. I only saw the first one. Pretty epic, and I sent him some info on it that can help him. So I sent where is Richard Hall? So I shared the email right here. So I sent Richard Hall an email and I put a bunch of links and so on. I will read some stuff here because again, people don't quite grasp how big this some of the stuff I'm sending is like. Again, from a theoretical point of view, it's mind-boggling. So there's Rich Planet. So I emailed him because he in the video, his first video, they said if you email me if you have any suggestions and so on. So that's why I emailed him. So I'm like, all right. So he's probably more open to replying because yeah. Otherwise he never replies because he has He gets millions of messages. But he did. What's interesting is Richard Hall actually read my like 2 emails he read in his earlier videos on blockchain and cryptocurrency. And I had a good track record too. So if you followed the advice from there, you could have made a lot of money. So anyways, I said, hi Richard. It's a great idea for starting Rich Planet Power. And basically, yeah. So he's gonna start basically focusing on Rich Planet, basically creating replicating free energy devices, or people that claim that they have free energy device. He's gonna replicate it and see the results. And then he wants to focus on that as opposed to just the usual conspiracy stuff he's doing. This will probably keep him out of legal trouble, but then this one might get him physical trouble. He might get someone showing up to his house with a. But anyways, okay. There's Hudson. If let's go. I built my own tri-magnetic trap for my nuke unit. It's on the cover of my YouTube. Holy, okay. John Hudson in the house, guys. You know what that means? That means we stop everything and then open his channel. Go to channel. So this means we stop. This one right here. Is that the confinement you made? Try magnetic field. And also, John, I sent you an email. I'm not sure if you got it. I sent you an email. Also, this is John, the other guy, Paul Stokowski, or whatever. How do you pronounce his name? See this?
Stoichevsky.
Stoichevsky, yeah. So Paul Stoichevsky. I got in contact with them. And yeah, so John, there's you and Paul Stoichevsky. Oh, Inventor 3's in the house. Inventor 3, just in time. I was about to go over your work there because I emailed Richard Hall. I'm not sure if you know Richard Hall, Inventor 3, but I highly recommend you watch his latest videos. He's going over the end machine. So the Bruce De Palma end machine. And I gave him the advice to put the magnets in repulsion instead of just a normal setup. So here, so Inventor 3, watch this first video. And I haven't seen a second one yet. But I will watch it because the Rich Planet is going to be replicating free energy devices. Yeah, so we got Inventor 3 guys. We got Hudson Effect. We have literally a star-studded chat right now. Okay, and we're gonna and just in time I was reading the stuff. Okay, you're offline. Okay, I don't know what's up with Odyssey. Oh, we'll see the Rumble. Nobody in Rumble yet. Anyways, let's go back into the setup here. So I'll show you the email that I sent. But also first of all, first I want to go back. So John, I sent you yes, basically, John, if you can forward me the code. I'm trying to help you log into your email, but I'm gonna check the email again. I'm gonna, if you can email me the code, and I'll help you log in right now. We'll do it right now because John's logged out of his Facebook again, and I hate when that happens. I'm gonna open up a new private browser. I'm gonna go FB. I'm gonna say forgot password. Okay, so John, if you get a code, send it to me. Okay, please searching the thingy. So John, please check your email. John John KH at 25 at Yahoo. Send me the code you get, and I will put this in there, and then reset your password. All right, please send it over there if you have it. Let me know if you get it. Okay, I'll tell John. Send me code, John. Okay, then I'll update the password, and I'll keep track of your password, just similar to what I do with the YouTube, so that. Because he was logged out of YouTube and he had to create an account, but then I helped him get back on. Because again, I don't want you to get a million accounts. Just get one account and then you're good. Anyways, so I am John's. But anyways, yeah. So John. So I talked to Paul Stoichevsky yesterday or 2 days ago, and yeah. So for those who don't know, Paul Stoichevsky is actually somewhere out there. So he's actually was the partner. Of Dominique Radwanski that made the Somewhere Out There pilot episode. And yeah, so she passed away in tragic stuff. Anyways, he told me about it, pretty tragic. So he messaged saying, talking about copyright and so on, saying how do you get these videos and so on. But then I told him the story, and then he let me on there. But I just sent him all the money I make from here. I just send it to him. And so on. So then he's also working on the finished pilot, and I will get him on the stream for future once he's ready and help promote it and so on. So again, he made the pilot episode with Dominique, and Dominique again passed away 2016. All right, and yeah, so I sent to John, please send me code. So okay, so again, let's go back in the story. Go back into the goods. Okay, so now the Richard Hall. Yeah, so Richard Hall. So I sent him an email, after watching a show. So again, Inventor 3, this will be relevant to you and John, because John knows Bruce De Palma. So John knows Bruce De Palma is the real deal, so which is interesting. So those two videos, design and build an end machine to investigate claims. I'm going to read this for you just so you read the initial parts. So Richard D. Hall launches Rich Planet Power, a project to investigate energy technologies. All right. And then this part 2 is Richard explains his design and build project to produce a basic version of Bruce De Palma's end machine. So he created a mini end machine in order to investigate the claims of free energy. The machine incorporates some of the strongest available magnets, N56. Holy, okay, so the one Inventor 3 you had was N52. So rotating at 3,000 RPM, driving a high electric current. Some preliminary tests are carried out. Also discussion of Bruce De Palma's end machines. Viewers are advised to watch show number 314 before watching in order to set the context for the show. Yeah, Rich Planet is great, definitely. He's what helped me get on the Judy Wood train. So again, his work is invaluable. And again, that's why him and Andrew Johnson, when they cover stuff, nowadays, yeah. So I only covered the moon landing because they did, and but that's one thing. If I do get on the show, I'll try to tell him, hey, you probably probably need to retract some of the claims. But anyways, going back here. Okay, whoops, to close the vector. I'm gonna open this one. I'm gonna go back to the email. So I sent him an email. So I said, hi Richard, great idea for your starting Rich Planet Power. I've embarked on a similar test of goal of testing free energy claims, and the Bruce De Palma end machine is the first one in mind. On my mind, I have other ideas I would like to explore, but my skill set is more aligned on the theoretical, mathematical, and experimental side of things. So it'd be great if we can collaborate in some way, especially with your technical know-how in electrical engineering. Again, Inventor 3 similar. I mean, yeah, Paul, similar to how we collaborated. Like I told you basically what kind of experiments I wanted with your drop test, and then you did them, which is absolutely amazing. So I think the drop test is again the fact that it's the only one in the world online that you can see publicly. It's probably because it's just super key. So to provide you with some information, here are a list of links of what I've covered before. So this was a live stream discussing end machine and gyroscopes in general. And then the gyroscope one is the one where it's like I'm trying to, it's like I'm talking to a wall when I'm trying to illustrate how mind-boggling they are. So this was the live stream in September 30, 2023, so 2 years ago. This was exploring gyroscopes and Bruce De Palma's end machine. So I went over that. And basically, and I also have this MES physics playlist, which I've started, and it's a lot of it is taken from Fractal Woman's work, and it's right here. So definitely check out Fractal Woman right here. I highly recommend watching it like 4 or 5 times until you grasp it. If you don't grasp it, guys, please ask me any questions. Grasp what this means. It's absolutely, I think, illuminating. Okay, so I said much of this was taken from Fractal Woman's research on YouTube. Of importance is the magnetic field isopotential lines. They represent the true magnetic field rather than the typical flux lines. Okay, Inventor 3, thank you for showing this end machine long history. Yeah, definitely. And yes, so rather than typical magnetic flux lines. So note also the experiments on Faraday's paradox, which are further confirmation for the magnetic isopotential lines as being a better description of a magnetic field. And then I also give him a link to my MES experiments playlist. So in my opinion, gyroscopes represent the simplest proof of free energy, anti-gravity, anti-inertia, anti-mass, and torque over unity. This one right here for sure. But it's like, I tell people that and nobody knows it. Like, nobody takes me seriously. But I'm telling y'all, a gyroscope is literally anti-gravity and free energy. But it's like nobody can, it's like, it seems too simple. And also here's this is oh no, I accidentally typed Faraday. I mean Fractal Woman's YouTube channel, not Faraday. But I searched Faraday just to help understand the Faraday's paradox, which is similar to the Bruce De Palma's end machine. And I will try to simplify it for those who this is not so it's not a paradox. Yeah, Inventor 3 definitely. And then I also said right here, I'll go back to the email. So lastly, here's an example of a collaboration I did with Paul Mueller of the Inventor 3 channel. And I put the link of our drop test, your drop test, my editing. So he showed that the magnets dropped in repulsion fall much slower than their attraction counterparts. Also interesting is the massive magnetic Gauss readings at the center of magnets and repulsion. And and this is this is the link of the longer one if you wanted to watch. I've included photos of the specific MES videos. I didn't double check the spelling, but anyways, that may help with understanding the end machine as well as the results of the magnetic drop test. Perhaps you can attach the magnetics, the magnets and repulsion on the copper disc for your end machine. So there it is. If he does this, he might get a big boost. I'm feeling. And also tell him, feel free to call me. There's my number. And if you want to discuss further, and if you want to do a show together, either on my channel or yours. And here's a live stream I did with Paul Mueller and John Hutchison, and they're in the chat right now. Let's go. So I put a link to the ones that will help with the end machine. So magnetic isopotentials explain the Faraday paradox, Stern-Gerlach experiment, and atomic orbitals. And then these ones here, again, I got these from Fractalman, so I did these tests. Faraday's paradox using iron filings, Faraday's paradox using ferrofluid, and so on. And then here's the results of the drop tests. And the key one right here, this is N52. Richard Hall has N56, but his was 15,000 Gauss. But we're able to get with an N52 at the center point 8,600 Gauss. All right, so we get half a strength, and these are tiny magnets. Like these are literally just tiny magnets, and reading super powerful strength right here. Just posted something and it never made it. Okay, so that's live chat. Yeah, again, and also so before I get further, I think Tammy, Tasha, I think you made the in Leo / peaked account, because I think I made a comment right here. Replies, comments, and then I commented right here. Oh yeah, so this was about the short post. I think you shared this one. This is your channel, I think, Paintress, and you put status update. But the thing is, this is typically made for like article or longer ones. So if you want to use, you could use a snaps thingy. This is which YouTube is this one? It was a quick hello and something about Bart Sabrell.
Hello everyone. I would like to present.
Okay. Yeah, Bart Sabrell, wonder what he's doing. But anyways, for short posts on the Hive blockchain, just because you don't want like people downvoting from big whales. But basically, use the snaps feature on Peaked, like for short stuff. Like these are just like tweets. And if you want to do longer ones or more, just more complete stuff, you can post it on as an article. So just to give you an example. So this, yeah. So like for example, this is like a post, so it's a long article. But you can also do short ones, but the thing is, it's kind of like use these snaps thingies, or in Leo one. In Leo threads is like, they made it focus strictly on like tweets and stuff like that. So like this kind of stuff. So you can go, and it's all in the Hive blockchain, it's all in your account. So I'm going to go summarize this one right here. That summarize. And if you also do a explanation summarize, it will summarize it in AI, so take the transcripts. Maybe YouTube blocking. But I don't know what I'm doing, but I knew I can make easy posts with YouTube uploads. And you could also do a post right here. You could also, if you click video, you could also do shorts here. You could upload a short on threads. So you could upload a short video as well. But here's and it's going to summarize that video, and then we'll get back on the show right here. I'm going to close some stuff that, yeah, so there's just somewhere out there. So I talked to the guy who helped make it with Dominique. So, oh, and there's John Hutchison's channel. Yeah. So Paul Stoichovsky, I think that's how you pronounce it. Anyway, so magnetic confinement. So yeah, that's I think I grasped it. Basically, you get the stuff spinning and use magnetic fields. The properties of electrons and charges, they just move with the magnetic field. So you just confine it, and so on. But anyways, that's the general point. There it is, and so on. I'm gonna close some stuff. Okay, it's back to end machine. Well, going back to the end machine. So yeah, this is the Gauss reading. So Gauss reading is huge, but here's the key part about this drop test. So again, here's the, if you look at this one right here, 57 seconds going down 6 feet. And then if you put it in attraction, so now the magnetic field is stronger, but then it's not that much stronger relative to the weight. The weight's gonna be, now it drops 37, so 35% faster. Not there, just here under this name. No, I'm not on there. Just here under. Okay, so I'm wondering who the other person was. It might be Tammy then. Okay, so never mind, Tasha. I think that was a Tammy. That's a different person. So I get yours confused with Tammy and Tasha. There's another. Oh yeah, Tammy. Okay, I don't know what I'm doing. Okay, so again, there's Tammy. Yeah, so I keep getting mistake Tammy and Tasha because it's like the same name to me. Okay, but anyways, and then if you have a magnetic repulsion, this is the it goes literally double the amount of the ones in attraction, double the length, and then it takes longer to drop than the individual magnet, even though it's double the weight. So that's the one I said, and I told him to use that with the end machine. And I will go back to the setup right here. Explain Bruce De Palma's Okay, or make a table of Bruce De Palma's end machine setup in comparison with Faraday's paradox. Let's see what it makes on Grok AI. Basically, the whole idea is Faraday's paradox. And I will play the video, okay? Again, guys, this is super important, so I'm going to play the full video right here. And first of all, here's another part of it. I'm like getting... I think I might just play everything here so you guys can grasp it. This like I can't just tell you to watch this. I need to like show you. And okay, we're going to play the first video. An electric... So basically, here's according to mainstream, so an electric current through a magnetic wire. Yeah, basically, if you have an electric current through a metal wire, like here, so basically it spins around, produces a magnetic field just like a permanent magnet. So there's a magnet, there's a current going through a coil. Through a metal wire produces a magnetic field just like a permanent magnet. The magnetic field is the shape formed by iron filings in the presence of a magnet. Yeah, so whenever you see magnetic field, all they're saying, this is the flux lines are basically the shape other little magnets will form. and iron filings, they basically get magnetized when there's another magnet. And then basically what you're seeing is a bunch of small magnets lining up with a bigger magnet. So in other words, this is the field. The field is just the shape of iron filings. Of a magnet. An electric field represents the force between electric charges. Like charges repel, opposite charges attract. Yeah, so basically in the electric field is just in terms of charges itself. So like electron, proton, and on other stuff like that. And basically the field is how they want to move to it. And again, notice how it moves it like that over there. The magnetic field resembles the electric field of two separated charges. Yeah, so going back here. So magnetic field literally just looks like an electric field. The only difference is these are separated, so now you have a part going from here to here. Nothing is going from here to here. Thanks for the great stuff. My lunch break is over. See everyone again soon. Okay, have a good one, Inventor 3. And we'll let you know about how this all goes, because I think your repulsion experiments, it's absolutely amazing. And there's one thing I'm good at is promotion, and and so I made it well known to a lot of people. And yes, thank you. And I do have a feeling I'll ask you for future experiments to test out. Anyways, continue further. So magnetic field represents the electric field of two separated charges. So they look similar. So this is how iron filings would appear on a magnet, and this is how the electric field is. It charges. Electric field simulator. Okay. The electric field matches the simulator. Yeah, so anyways, there's an electric field simulator. We can go play around with it. But if you just put true charges, I just wanted to show that it follows the same Wikipedia image. And now what happens if I put them all together? So that's going to be an interesting one. The magnetic field resembles the electric field of two bound charges. Yeah, so I put two charges together, and now it looks just like this. And now if you put up a whole bunch together, now you literally form exactly how so the electric field becomes identical in shape, or in just qualitatively identical to a magnet. Is a bar magnet? Yeah, to magnetic field. So this is a bar magnet. If you put a bunch of charges in line like this, opposite, like basically this is in negative, positive, put them all together, you get what appears to be a magnetic field. Just a collection of many bound and aligned charges. The magnetic field is the... Alright, so that was the first one. So basically, you got that in your noggin. So a magnetic field is just electric charges bound together. That's the question I raise. Again, this is from Fractal Woman's work. And now here's the big one. The magnetic field is the shape formed by iron filings in the presence of magnetic field. Now we're going to deal with magnetic isopotential lines. Explain the Faraday paradox, Stern-Gerlach experiment, and atomic orbitals. And we'll go over how this helps for the end machine. So, and then I'll send Richard Hall this video too, maybe. Like, here, check this out. Okay. So if we go magnetic field is a shape formed by iron filings present magnet, and yeah, so this is again that's how put iron filings is just a small piece of iron, and magnetic field just a magnetic bar magnet, and that's the shape. That's the shape that you draw.
The shape formed by iron filings in the presence of a magnet. An electric current through a metal wire produces a magnetic field just like a permanent magnet.
Yeah, so going back here, so there's a coil, and then if you send electric current to, again, iron filings behave exactly like how they would with the, exactly how they would with this right here. So you have these going in like that, and basically, yeah, so current basically is rotating the ether. And then the it's like moving the ether particles in there, moving the objects.
Magnet. Using Michael Snyder's Pick-to-Mag app to plot contours of equal magnetic field strength.
Yeah, so this is the big one is when I say magnetic isopotential lines, what I'm trying to say is the lines of equal magnetic strength. So if you have a magnet and you just measure wherever it's like the same, and you plot it out, that is the I think more important quote magnetic field. Like that's the one that should be referenced as magnetic field. And then every time you see the iron filings, that's magnetic flux. So whenever you see those, think flux or motion. Don't think magnetic field. Think the equal potentials are the magnetic field. Go back further.
You can find this at pick2mag.com.
So I downloaded it. There's me making it. Okay, then I think I do a speed up version. Oh no, never mind. I do it after.
These magnetic, quote, isopotential lines are perpendicular to the magnetic field.
Yeah, so basically these lines are all the same strength. So if this is, let's say, 1 Gauss or whatever, and it goes all the way around, and it just calculates, it just draws it out. How does an electromagnetic gyroscope work? Electromagnetic gyroscope? Well, not sure exactly what you mean. We will look at that in a bit.
A close-up of the magnetic field and isopotential lines. The magnetic field lines can be thought of as many smaller magnets surrounding a bigger magnet.
Yeah, so again, these little things are small magnets, basically iron filings, they all get magnetized. So basically, the magnetic flux lines are just small magnets, and then they all align perpendicular to these equal potential lines. And yeah, that's how they all align.
Bigger magnet. The isopotential lines are perpendicular to the magnetic field.
And notice there's a big giant bulb. And again, what do you see this bulb everywhere? Everywhere in atomic orbitals, even the two hemispheres of your brain. It's very, very similar. So again, it's I think it shows up a lot in everything. And we'll go over this electromagnetic gyroscope later. I'm not sure what you mean exactly. Once I go through these.
Field. Fractal Woman illustrates the magnetic isopotentials by measuring the voltage or electric pressure around a magnet. Magnetic isopotentials can be thought of as pressure gradients. Each dot represents a 0.06 volt reading at a distance from the magnet. Fractal Woman's voltage readings match the isopotentials plotted from Michael Snyder's Pick-to-Mag software.
Yeah, so basically what she did was she got a magnet, and then just measures wherever she gets a 0.6 volts on her, measures the strength. Whatever that voltage is that much, she just puts a dot there, dot, and you basically get a perfect blob like that.
Voltage readings match the isopotentials plotted from Michael Snyder's Pick-to-Mag software. The isopotential lines are actually 3D surfaces. The 0.6 and 0.7 volt readings are shown.
Okay, yeah, so notice the big bulbs there. All right.
Pressure gradient equals change in pressure over a distance. In the case of air pressure, large pressure gradients have closer isopotentials and strong winds are expected. Small pressure gradients have more spread out isopotential lines and weak winds are expected.
Yeah, so and from this looking at the pressure gradient, this is why when you see like weather stuff, they show you this is what they show you. They show the actual gradients so that all these areas are the exact same wind speed or this is surface pressure. Yeah, basically exact same pressure. So the air pressure here is all the exact same. Whenever you have close lines, they're all basically what they're saying is that the pressure is super high. So in other words, there's a big flow of air. So just by looking at this, you'll see that this part here is going to be really windy. This part here is not, and especially this one here has all the exact same pressure. Nothing's going to happen. Nothing's changing.
Expected. Likewise, for a magnet, large pressure gradients have closer isopotential lines and strong flow is expected.
Yeah, so similar to this, when you draw the magnetic isopotentials, whenever you have these bunched up lines, that's where you know that's the strongest flow. And then this one here is the difference between here and here is super small, so that's why it's, yeah, I mean the pressure from here and here, or the strength, yeah, they have a really far distance, but it's the same difference between like this one right here and here. So this one you're expecting a big force, this one not much. Okay, so you want to ask Rock, but you reach your daily limit. Okay, we'll go over the electric gyroscope right now, and then just because you're it's math Q&A, and we'll get back onto the show. Okay, there's setups there. Oh, and then mid is right here. Definition: homopole generator rotates magnetized conductor. Okay, we'll get into this. Yeah, again, Grok is taking over the game. Or I'm gonna go. Instead of asking Grok, just what is an electromagnetic gyroscope? I'm not sure exactly what you mean. Electromagnetic gyroscope. It's an invention. And when was this from? 1984. Includes a magnet for generating magnetic field parallel to the axis and conductive path traversing, and a sensor for sensing a potential difference between first point, second point, and conductive path. So let's go. This is like a sensing. Okay, how does? Electromagnetic gyroscope propulsion system. Nuclear. Is this what you mean? Nuclear magnetic resonance with gyroscope? Okay. Oh, this is Chris right here. Okay, yeah. So this was the biodigital convergence. Yeah, he liked it. Epic stuff. Okay, anyways, propulsion system. But again, I'm not exactly sure. Well, what in the world is? I don't wanna. Okay, I'm gonna open this right here. Okay, Grok, I'm gonna keep this right here. I'm gonna go. How does a electromagnetic gyroscope? And then I want to go back to the physics setup there. Oh, you meant this one? MEMS an electromagnetic gyroscope, or MEMS electromechanical system gyroscope, or vibrating structure gyroscope operates by leveraging principles of magnetic fields and Coriolis effect. So it's not really a gyroscope. Yeah. So when they say gyroscope, it's not actually a spinning thingy. It's just like a vibrating one. And now, whenever you have vibrating and there's motion, there's going to be a lag. In other words, a Coriolis effect to measure angular velocity rate of that, and so on. I just came up with it. Oh, you just came up. Yeah, basically, I'm pretty sure what this is. But the thing is, you have to just describe it. Yeah, describe what you're. like describe it. Is the magnetic field rotating as a? Because again, a gyroscope is just a spinning disc. On an axis, like just spinning disc. It just spins, and then you just put it on a and then basically a gyroscope by itself it's so a spinning top is just a spinning disc. But then if you have another axis, so now it's like it's free to it's free to rotate a second axis. So like this is a gyroscope. If you build your own AI, you won't have any limitation issues, correct? No. Again, your limitation is your server, your computer, using your energy you're putting in. Everything's got its own limitations. So here's just gyroscope, basically a spinning thingy, and then there's another axis that could spin as well. That's a gyroscope, and the spinning top is just if you remove this outer one, put it on the ground, you just have a spinning top, and then a MEM electromagnetic gyroscope. I'm gonna go back into setup here. And this is there's different setups here. Basically, you have electricity going through, and then as they move. Okay, why doesn't it show the full thingy there? Plasma. Okay, this is just a plasma ring. Torus shaped. I think that's what it meant. MEMS gyroscope or something. This is just like a lot of the ones that you see. They're called MEMS gyro sensor, the electric one. It's like it just vibrates, and then if you start moving it, there's gonna be like a slight shift from the like these will all detect slightly different voltages or current or whatnot, and then from that you can detect if it's rotating or not. So basically, a lot of it is just experimental stuff. So you just shake it, and from there you can detect where it's moving. So here's a zoomed in one. So if it's vibrating, when it's flat, you're gonna have a certain voltage, and then when you rotate, some of these will be closer to it, some won't. Since you showed that gyroscopes go up when they lose torque, well, no, when they lose spin speed, they go up. Yeah, when they lose spin speed, not torque. Okay, yeah. So the gyroscope is rising on their own as again, it's nobody's come up with it. Nobody. Well, there have a few people in the world, like literally like a handful, publicly that have mentioned it, but in like without they don't even understand how big it was, and I'm the only one that's made like a million videos on it. So if you search gyroscopes rising on their own, you see all mine. So gyroscopes rising on their own, it's all just MES. How do gyroscopes lift themselves up? Oh, I think this was a disinfo agent guy. Oh no, this person.
Today
no, okay, this one he covered it after like 2022. I was from 2017, and he still doesn't even know. And he references a paper that doesn't even talk about it. It talks about spinning tops. But anyways, he doesn't actually know what's rising. But then every other video is mine. He just has like 1 million subscribers, but mine should be first on everything. Yeah, there it is on Google. I'm first there, rising, and then there's that guy. But he doesn't actually explain anything. He just doesn't tell you. This is odd experiment gyroscope. So he doesn't actually know the reason. Okay, yeah. So it's like all just mine. Okay, can a hinged gyroscope lift a fulcrum and itself? Okay. Anyways, it's like nobody. So this is where gyroscopes are like where I am in my. Okay. Anyways, here's that thingy here. So here's a summary. So anyways, I summarized that video. And you put the AI in here. But anyway, speaking about the AI stuff, if you put it on Hive, you have an open source one that's run on Hive. It's like there's literally no limitations. Like I'm using an AI summary right here. I could do infinite of these summary bots. I could do it. This isn't one example of an AI one. Their current one I think is down or whatever. I'm gonna check. Hashtag Ask Leo. Are you still down or running again? They had an issue with their bot. So like if this one here, there's no limitations in terms of like using it. You have unlimited as long as it's working. But again, it's you're comparing it to like $1 trillion companies. But the thing is, it's open source, so there's very little backend, and it's all in blockchain and decentralized, so they can literally just run on its own. And I'm gonna go right here. Okay, so I'm gonna go back to that physics one, and then to help you grasp the end machine.
First set of
also for myself. Okay, so we're back to right here. So again, think of this right here. Whenever you see a magnet, think of these bulbs. You don't think of the typical magnetic field where it goes up and it just circles. This is an actual bulb.
Small pressure gradients have more spread out isopotential lines, and weak flow is expected. Magnetic flux equals ether flow? Question mark.
Yeah, there's a question I had. So magnetic flux is ether flow.
Ether flow? Question mark. Fractal woman demonstrates magnetic isopotentials on a level table. The table is perfectly level.
Yeah, so it's not rolling anywhere. Again, it's super important. Here's just a ball bearing. So to illustrate the magnetic isopotentials, again, I can't stress this enough because see, it's perfectly
a small magnet.
So here's a magnet, and then she has a little tiny magnet right there. The question is, and there's the that's the north pole. There's a south pole. That's the center line of block wall or whatever. Goes both ways. A small magnet tends to roll along its current magnetic isopotential line towards a bigger magnet. So if you have a magnet, it's not going to go the shortest path. This is where the key part is. It's going to go around in a circle. All right? It's going to go around according to its magnetic isopotential.
Magnet tends to roll along its current magnetic isopotential line towards the bigger magnet.
And the only time it launches is once it gets super close to where the pressure's super high. So it's not a simple flux thingy like everyone's just going in. It's actually flowing perfectly along that lines. Yeah. So here's the graph of isopotential lines from the 3D software. Oh, I mean from the Snyder software. And then it follows it. It does not go straight to it. That's the thing. But the strongest magnetic field is right here. So the question is, why in the world would this magnet roll this way? All right. Why would it go to the right then there? Watch. See that? Perfectly in line. Again, I can't stress how important this is.
Even placing the tiny magnet at the left can make it go to the right while going along its current isopotential.
Yeah, so even if you put it over here on the left side, instead of going it straight, it's going to go literally the farthest path until it gets to it. It's going the farthest path until it goes to it. So and look how far away it goes.
The small magnets have their own isopotential line.
Yeah, so basically think of their own isopotential lines, and then the middle point is like where they're already comfortable, they're already aligned. So they don't want to. It takes some force to rotate them. So it's going to keep going until they're super close, where now they're interacting with the pressure super high. They're really close to the other line. Again, basically the closer lines means higher pressure. This one's low pressure. It can keep going its own path forever until it gets closer to that, and then it gets launched because it's just too powerful.
The small magnets follow the path of least resistance. Tiny magnet still wants to align with an isopotential line even if pushed forward towards the bigger magnet.
Yeah, so this is a big one. This is, again, if you hit the magnet forward at, again, the strongest magnetic field, it still does not want to go there. It still wants just to roll to the right. So it's like, okay, so how do you explain this? Do they curve due to spinning like a curveball? Yeah, they're rolling. But they curve because they're following the magnetic isopotential lines. Because they have their own magnetic strength there. So they want to mediate the path with least resistance so they don't turn around or anything. So they're going to line up and they want to go there until they have to go.
Forward towards the bigger magnet.
So you hit it, it's still going to go to the right.
Tiny magnets tend to move along isopotential lines even when the large magnet is placed on its side before then flying to the poles.
Yeah, so you have the magnet here, north and south. So a little magnet, it's not going to go to a north or south. It's going to go down the center, and then it's going to go to a pole, depending on how it hit it. All right? And it's going to go follow the magnetic isopotential lines. Yeah, so... And watch this one. Okay, and it instead of going straight to the poles,
when placed really close.
But if you look at them, all the magnets are now at the poles. If you put them right here, they're gonna fly. But if you put it over here, it's gonna hit the center first. When placed really close, the tiny magnet flies directly to the pole of the larger magnet. So when you
the tiny magnet flies directly to the pole of the larger magnet.
So that's basically the pressure's too high for it to go according to the current one. So the pressure's high enough to rotate the magnet and throw it into it. But then if you go far enough, look how far away. If you go far enough, it rotates.
Tiny magnet or steel ball bearing can be placed at the side of the larger magnet, but it is unstable.
So this is what I mean. It can mediate its pressure on the center of the magnet. You have a tiny one because the poles are perfectly aligned. So it's like perfectly aligned. But then the second you nudge it, it's going to go to the end. Just keep that eye.
Slightly tapping the tiny magnet causes it to fly to the poles.
Yeah, so again, that's pretty interesting. So again, it's all pressure mediation. So like if you have a fluid like water, it's gonna go to places of lower pressure. So for example, if you have even let's say a balloon, if you have a balloon, it's high pressure, and then once you poke a hole in it, it's gonna expand to the areas of low pressure. That's all this is doing. But this time we're dealing with ether. It's a high pressure. But you can balance it slightly here the second you get off The second you get out of balance, the pressure just goes to over here. Anyways. And magnetic isopotentials show the unstable configuration. Any slight deviation from the perfect balance will cause the small magnet to fly to the pole of the larger magnet. Yeah, so here's what I mean. If you put on the like in line on the center, you can see how they're perfectly balanced. There's a yin and yang, and then but if you nudge it, it's gonna go stronger on one side, and the pressure's so high that it's gonna fly over it. All right, so that's when it's super close. When it's super far away, it's gonna just stick around this this orbit right there. The Stern-Gerlach experiment involves a beam of electrically neutral silver atoms moving through a non-uniform magnetic field. Individual atoms are deflected either upwards or downwards, but never in the middle. The mainstream explanation is the silver atom's unpaired electron is either spin up or spin down. From the all right, so going back here, so you have a atom in a silver atom. It has an unpaired electron, so basically has a charge, and then there's a magnetic field right here. They just have it sharp here, but then what they launch it at is at the center of the block wall. So similar to back here, they launch it exactly similar to this setup here. They launch it literally right at the center, and then it passes through the magnet. So if you imagine you have a magnet going from here and then right through the center of the magnetic field, and then it either goes up or down. It never goes in the middle. And the mainstream literally says, oh, it has a spin up, spin down, mumbo jumbo. No, it's just a magnet going through another magnet, and it goes up or down because those are the isopotentials. So again, here's where how big this kind of stuff gets. Experiment involves a beam of electrically neutral silver atoms moving through a non-uniform magnetic field. Individual atoms are deflected either upwards or downwards, but never in the middle. The mainstream explanation is the silver atom's unpaired electron is either spin up or spin down. From the perspective of magnetic isopotential lines, the silver atoms behave like a tiny magnet passing through a large magnet. The tiny magnet. Okay, 29,000. Is this used to build an machine? We'll get to it in a bit. This will help explain an machine, or just to help understand it a bit better. We'll get to that machine soon. We have 35 minutes. I want to play the full MES physics because I don't want to just be like talking and then like to myself because nobody else grasps what I'm trying to get at. So basically, what I'm trying to say is keep this in your brain and watch those MES physics like several times until you have it fully ingrained into your head. Like the playlist right here. Make sure you watch every single one of these and engrave it into your head, please. Like I can't stress this enough. And then we can talk the same language. Otherwise, when I say magnetic field or magnetic isopotential lines, and then you're like, what? So keep that in mind. So basically, it goes like here and it follows along here. We'll get to how the end machine how it's related to it soon. And it exits along an isopotential line, either up or down. So basically, instead of saying there's a spin up, spin down, it just literally it's just a tiny magnet going through a magnetic field. So again, we've simplified the Stern-Gerlach experiment where you don't need to learn a bunch of spin up, spin down, quantum mechanics, mumbo jumbo. When stacking many magnets together, the magnetic strength is much weaker in the middle and much stronger at the sides. But I can easily move. There's another part here. If you stick a bunch together and then you get the isopotential lines, they all just literally line up like this. This is from the 3D software. And here is the actual experiment. Stronger at the sides. But I can easily move it, see? Easily move it. But when it gets to the end, I cannot move it. I can no longer move it. It holds the whole string up by holding the ball. Okay? Visualizing the isopotential lines in 3D. Yeah, that's some 3D software that Fractal Woman had. I think it was from her work. This is from her, like her MRI stuff. That she says she couldn't send it to me because it's like her company's or the place that she works at. Yeah, so she can't actually send it. So I wanted to get hold of this, but that is expensive stuff. When viewed from the poles, the isopotential lines form concentric circles. Okay, now we're getting in Faraday's paradox. So here's Faraday's paradox is related to the end machine. So here is the setup. Faraday's paradox basically says that if you spin the magnet, not the copper disc, then like it's supposed to, when you spin a magnetic field, it's supposed to induce a current, but it doesn't. It only induces when you spin this one. Even if you spin them together, this is the key one. And the reason is because the isopotential lines don't change.
Explained. Rotating magnet does not induce a voltage at the poles because the isopotentials don't change at the poles. Spinning the copper disc induces voltage because the isopotential lines or pressure gradients of the moving electric charges changes in space relative to the concentric isopotential lines of the spinning magnet.
Yeah.
Faraday's.
And then here I go over that. It's basically, yeah, when you spin this right here, yeah, this is viewed as like a whole bunch of these small magnets. Those are going to be inducing a current on this because this magnet is just one big giant one and nothing changes. These isopotentials are literally just circles. And this one here, you have little tiny ones that they're every second it's moving, it's changing.
Faraday's paradox can be visualized using a magnet and iron filings.
So here's my experiment.
Moving the
So if I move side to side the magnet, the iron filings move.
magnet moves the iron filings. However, rotating the magnet has no effect on the iron filings.
Yeah, so if I rotate it, but remember, if you think of it as a giant bulb, the isopotentials don't actually change. So the iron filings aren't moving. So in other words, this is just Faraday's paradox, a physical analog. And the iron filings are just stationary.
Atomic orbitals are regions around an atom's nucleus where there is a high probability of finding an electron. The orbitals may have different energy levels and shapes, yet all of which match the isopotentials of corresponding configurations of magnets. Perhaps the magnetic isopotential lines should be called the magnetic field instead of the magnetic flux or flow lines.
Yeah, okay, I want to pause that before I switch to the next video. So these are electron orbitals, the probability of finding electron. And there's a positive charge. I mean, not positive. This is just a different place you can find it. And there's the other one. So you could either find it in the center or on the outside. And it's right here. But then if you, this is that 3D, this is that Snyder software finding magnetic isopotential lines. So if you just put literally a bulb there as a positive, and then and then this is the shape you get. You literally get this shape. And then if you have two magnets right here, magnet here. No, I think this is a magnet, and this is the other magnet. I think this is this one. How did they get this one here? But anyways, so if you just put two bulbs, one positive, one negative. And then like this is literally what happens. So in other words, the isopotential lines of these would be assuming electric charges. I think that's how they did it. But anyways, so this center one, I think that as positive. Yeah, this would be positive, and just put a negative charge all around. And then if you graph the isopotential lines, it's literally the exact same. This is just from the simple magnet isopotential lines right here. So the isopotential lines of the magnet or the electric charge, which are again the same, according to the first video, or similar, or related. And again, it's these are isopotential lines. This is just, these are isopotential lines. These are magnetic orbitals, and these ones have complex equations and so on. This is just finding the equal magnetic strength, match up exactly like this, and for all different types as well, orbitals as well. So again, now we'll go to the next one. So here's the iron filings one I made, just to test it out. Yeah, so I did the experiment. So again, when you rotate, nothing happens. But if I rotate that affects it. And then if I rotate sideways, here's sideways. It's pretty cool. So here's I install this the axis horizontally now, the spin axis. No, I mean the pole axis is horizontal, and then now we're spinning the actual magnetic field. So here's what happens when you spin the actual isopotentials. It circles around in a circle like that. Now if it's sideways, you can move it. Now here it is parallel, you can move it around anywhere you want. Alright, and then I did the same thing with ferrofluid just to illustrate how little anything changes. So I'm spinning the magnet underneath it. Nothing's changing. Like the actual shape is not even being affected. Again, that's Faraday's paradox. Basically, it explains with, and then here's another one. I'm rotating by hand slowly. So here's the shape. If I rotate, nothing changes. It's literally perfectly still. Even if you make a super complicated one and you rotate, nothing changes. Yeah. So basically, this helps understand. This helps understand the Faraday and the Bruce Thomas. Okay, I'm gonna go to the washroom and we're gonna dive into. I don't think there's another. Yeah, the next video is just Planck's constant is energy constant. It is a quantum energy.
In class.
This one is going back into basically saying that the quantum mechanics is actually it's based on a faulty premise, which is a. Anyways, I'm gonna I'll play this and go. Actually, no, I'll just keep it here. Just grasp this. I'm gonna go to the washroom. I'll be back. No, I'll play this and I'll come back. We go to the washroom, and then we'll see what happens.
In classical mechanics, the energy of light is continuous, but this doesn't always match observation. In quantum mechanics, energy can only take on discrete values, however, the units are unbalanced. The equation E equals h times F is Planck's energy frequency relation and is the energy of a single quantum of light called a quote photon. In Fractal Woman's modified unit analysis, balancing the units of the Planck relation formula reveals a minimum unit of energy. In quantum mechanics, the energy of a quote photon is quantized by the following equation. E equals hf, where E is the energy, h is the Planck's constant, and f is the frequency of light. Frequency is the number of cycles or oscillations per unit time. The international standard or SI unit for frequency is Hertz, which has base units of 1/second or second to the power of -1. A pendulum is shown making 25 complete oscillations in 60 seconds, which gives a frequency of 0.416 Hertz. The Planck constant is referred to as the quantum of action and is associated with the quantum or minimal element of the energy to the electromagnetic wave. In SI units, its value is 6.626 times 10 to the power of -34 joules per hertz or joules second. When Planck's constant is written in units of joules per hertz, the energy equation is balanced. However, if Planck's constant is written in units of joules second, the energy equation is unbalanced since there is a hidden unit of quote 1 remaining. In Fractal Woman's modified unit analysis, the unit of cycles is accounted for using the delta or triangle symbol instead of ignored using the number 1. Thus, Planck's constant has units joule times second divided by cycles, and the energy equation is balanced. Accounting for the units of cycles reveals that Planck's constant can be interpreted as being the energy of one.
Alright, anyways, we could keep playing this one, but this one isn't directly related to animation, but definitely grasp this, guys. This is basically understanding light itself and so on, and then the mainstream, the whole quantum mechanics is based on a flawed. Well, basically, they every time when they say there's a new there's like a quantum of light, there's a photon. What they're actually saying is that there's 1 second worth of energy. And then there's a fraction of 1 second unit of energy. I'm just go back here. How do they calculate it? Yeah, it's basically this is the bug, is that they have this like random second there, random second term. So what they're actually doing is that, yeah. So let's say if you have here's the mainstream. I mean, here's the modified unit analysis from Fractal Woman. Basically, 1 quantum of energy is just going to be this one here. This is the 6.62, and you can't get any less than it. And then in quantum mechanics, there's infinite quanta of energy because you have this Planck's constant, which is Planck's constant, and then you have to multiply by the frequency. So somehow, the energy quanta is the frequency. Let's say this is the frequency is cycles per second. So how many cycles per second? Wavelength. There's this wavelength for this gamma ray, for example, would have 1.99 e to the so the h times frequency. So this is basically you would just do this right here. Yeah, Planck's constant times it by the frequency. So you have this per second for some reason. So in other words, this is the energy per second of a gamma ray. Of a gamma ray. So this is the energy of a gamma ray per second. But the thing is, a second is not a fundamental thingy. Like I could use an hour. What if I change Planck's constant to joules times hour per cycle? like what? So there's a random time variable in there that shouldn't be there. So in other words, all of these energy quanta, when they say that the photon X-ray have different photons, what they're actually saying is that they have different energies per second. I mean, but no, I'm saying they have different energy in 1 second. Quanta is measurable in a numerical value. Yeah, I know, I understand, but what I'm trying to say is they're saying that these are real photons that exist. But the thing is, they're calculating it by Planck's constant times by the frequency. But there's infinite frequencies. So they're saying every single frequency has its own associated photon or quanta, as opposed to, as opposed to there's only one minimum quanta, or quantum. And then, that's it. And then the number of those accounts for the energy of a gamma ray, for example. And you go back here. So in a gamma ray, for sure, okay. Time is agreeing with me. Yeah, basically, if you have 1 unit of time, a gamma ray will have more energy per that 1 unit of time. So we're not sticking to 1 second. So in other words, all the photons are stuck to 1 second of energy. Like how's that? What is that in the world? I mean, anyways, so we got that. Now we're gonna go back into let's say N machine. So here's N machine he built. I'm gonna go to the Bruce Palmer's. I think his website's still down. Bruce Palmer N machine. I think it's back up. It was down. No. So this is N machine, but the old one was gone there. Okay, so here's how it is. N machine design. Archive. Okay, they include Thomas Beard in there. I want to see Secret of the Force Machine. I just want to see some diagrams straightforward. Okay, so what does he have exactly? Yeah, we're gonna go back into this sliding contacts. I'm gonna go into Richard Hall's. I haven't looked at it. I'm just gonna play this right here. So here's a pro tip. You can click on the Odyssey one because I don't know why he posted like without even a title and so on. Doesn't even promote it or any way. Let's see some energy. What's the plan? We have 18 minutes. I just want to see how he did this. Yeah, I think he explains it right here.
Kilo 3000 RPM rotating flywheel, which could be deadly. So don't try this at home unless you know the center of the disc and the rim or ends of the cylinder or electrically conductive electric and have considered carefully how to do it safely. So what is a homopolar generator? According to Wikipedia, a homopolar...
Also, before we go further, there's an interesting ring that he's wearing. I want to check what it is. Because I want to double check if it's not a Freemason ring, because otherwise I'm... I don't know what's going on. 1 second, I had a screenshot. I have like ODD. This was a screenshot from before. I want to check what the ring is. Okay, we're gonna go to actually, I think I have it open. So this was a ring he had. I'm gonna zoom into this ring. So here's his ring that he's wearing. Just want to double check it. I just want to know what this ring is from. Hopefully it's not Scottish Rite Freemasonry. Then otherwise, what's going on? All right, let's check. Just double check some stuff. Anyways, here at MES, nobody's off the hook until. Okay, actually no, we have that already. Tin eye. Let's see what this ring is. Okay, so so anybody knows what this ring is? Google Images. I'm gonna ask Grok AI. Okay. Yeah. This is ring. Okay, could be just his wedding ring. Well, this was okay. The Freemason ring looks like that. That's no, actually no, that's not Freemason ring. But anyways, let me know the ring, guys. If anybody is an expert in rings, okay, that's a Freemason ring. But this one is it looks, yeah. So that's a Freemason. This is a Freemason ring. Okay, no, that's not. Instead of others which indicate ranking. Ranking in what though? Oh, it might be his engineering ring. Let's see, electrical engineering ring. So that's the ring like that. Gold Laplace. Okay, but Freemasons do have something like that. Anyways, but okay, no. But anyways, it looks pretty common. But let me know what that ring is, guys. I want to ask him. That was be the first thing if I get him on my show. We ask him, yo, what's that ring? In the lodge? No way. Like this exactly? So that's a let's say this one right here. I'm gonna see reverse it. I'm gonna ask Rock, guys. Here at MES we go through extremes. Okay, explain this. What is this ring? Oh, in the lodge, compass and square is a Masonic ring. I know, but this is not a compass, it's a square. This one looks like some sort of weird. Is that a compass? I don't think it's a compass. What is this ring? Or is that the double eagle? No, we'll do some zooming in action. You guys, here we're gonna find the ring. Is that a pyramid on top? I am not sure what that is. I will have to double. What is this ring? Okay, Grok AI is looking. It's probably like. What's the? Anyways, I do want to meet up with him, but I don't want to sound paranoid because he does that hand sign a lot. But anyways, let's play this.
According to Wikipedia, a homopolar generator is a DC electrical generator comprising an electrically conductive disc or cylinder rotating in a plane perpendicular to a uniform static magnetic field. A potential difference is created between the center of the disc and the rim or ends of the cylinder with an electrical polarity that depends on the direction of rotation and the orientation of the field. It is also known as a unipolar generator, a cyclic generator, disc dynamo or Faraday disc. The voltage is typically low, in the order of a few volts, in the case of small demonstration.
Yeah, 29,000 tons thermite. If RDH turned out to be a Freemason, I just delete everything, go live and live in nature. Hey, possibly, I don't know, because he does a hand sign a lot. But again, nonetheless, Freemason or not, he woke me up, so that's pretty good. But again, let's see what the here at MES we don't stop. Okay, if I click the
What's the plan? Work.
So like he does his hand sign a lot.
Any concepts about energy.
But again, I just gotta see what that ring is. Let's see what this thingy is. It does this a lot. Again, I have an obsession with hands. He hasn't done it in a while. Where's the hand side? Okay, no, he hasn't done it in a while. Where's the hand? Yeah, there's a hand. Okay. But again, it could be just a hand. He's
People
sitting
who
down.
you will see discussing these types of devices online. Very few of them actually go and build one. You can present as many equations.
All right. So anyways, that's just a typical hand sign. But here at MES, everybody is like if a Freemason talks about 9/11, I can get them on the show. Tell them, hey, he has to eat babies. But anyways, I'll go back in here. So anyways, so basically, this is a homopolar generator. You just have a spinning disc on a magnet. So you have a magnetic field and you spin a disc. And the whole Faraday's paradox is if you made the disc still but you spun this around, you're not going to get a magnetic. You're not going to get a voltage, current reading. And again, that's because of the isopotentials. So anyways, let's play this for. Okay, 20,000 tons thermite. Me too. He popped up where the towers go. Dr. Drew would book. Yeah, definitely. That's what I caught it. Go back to the Grok. I am very interested. Something went wrong. No, oh my goodness. Grok's not allowed to find out what this ring is. Possibly crest typical for used. Okay. Anyways, I'm gonna do a deep search. Okay, I'm gonna do a deeper search. Send. Okay, now it's gonna do super deep search while we're watching. Okay, let's do a deeper search. Not everyone in Lodge are initiated in the dark side. There must be good to attract masses. Yeah, but again, we're talking conspiracy people. If you're a conspiracy person, and you're a Freemason, you need to state clearly and show videos of your lodge. We don't want any secrets. Basically, it's like if you take an oath and you're in secret, then it's like, well, why don't you take an oath to truth? All right, let's go.
Models, but large research generators can produce hundreds of volts, and some systems have multiple generators in series to produce an even larger voltage. They are unusual in that they can source tremendous electric current, some more than 1,000,000 amperes, because the homopolar generator can be made to have very low internal resistance. Also, the homopolar generator is unique in that no other rotary electric machine can produce DC without using rectifiers or commutators.
Okay, so that's interesting. Basically, it doesn't need any other extra parts. So it can get direct current at high current, low voltage. And what's interesting is those the free energy power cells that John Hutchison has. It's the opposite. It has high voltage, low current, like almost no current. All right. So John, so then send me messages. All right. We'll find this out. But it looks like just as general. But anyways, anybody that finds... I once thought the Pope was infallible, but then I grew up and woke up infallible. Well, I think it's like infallible in terms of whatever he says or does won't change the outcome of the New World Order. Anyways, do you want to see that? No. We'll see that closely. Okay, okay, it's this weird shape. It looks like a weird thingy there. Let's see. Okay, so that's that there. Okay, I'm gonna go. What is a wedding ring finger? Because I know he got married like relatively early. Okay, so that's the this is for the guys. Which is the hand for man? My goodness. Okay, where's the guide? Okay, this is the front one. A guide to wearing wedding rings. Small hands, bigger. So it's index. And he has it in the... Okay. Yeah, so it's on the left hand on the other side. Kelly Pope's direct connection to God. Alright. Well, that's... yeah, but again, I think everybody is directly connected. So in a way they're right. You're looking the secrets out. All right, let's go.
As you like, and state as many...
Go back to the end machine. Where's the end machine? Right here.
Commutators. So let's come on to the N machine, named by Bruce De Palma. This is a version of the homopolar generator where the...
Yeah, so the typical one is just a spinning disc, and then you have the stationary magnetic field. But then he puts the magnet on it.
Magnetic field is generated using a magnet or magnets fixed to and rotating with the conducting disc, known as co-rotation. As explained in the previous show, rotating the magnets with the disc still produces an output voltage and allows for a stronger field through the disc because the magnets are actually attached to it.
Yeah, so he mentioned the Faraday's paradox in the previous one. And again, basically now it's spinning the disc and the magnet, and you get a voltage. And the reason he does that, the homopolar generator, as Richard explained, is because to get the electricity from here, there's a lot of losses from this wire setup here. Yeah, basically to get the electricity from this setup, there's a lot of losses. What happens is there's this big air gap. When you put the magnet literally on it and it's spinning, there's very little losses. You basically get current directly. Anyways, let's keep going.
This is a version of the homopolar generator where the magnetic field is generated using a magnet or magnets fixed to and rotating with the conducting disc, known as co-rotation. As explained in the previous show, rotating the magnets with the disc still produces an output voltage and allows for a stronger field through the disc because the magnets are actually attached to it. My machine is intended to be a smaller, simpler version of Bruce De Palma's N machines, so I named it the Mini N machine. During the design and build process, I changed various aspects of the design as the machine was being constructed, and I will explain all of this shortly. I'll first run through the specification of the finished Mini N machine. It has a lower base plate made of mild steel. This is 350 millimeters square, 20 millimeters thick, and it has tapped holes to incorporate fixing bolts. It has an upper base plate made of wood. This consists of 2 layers of scaffolding board and is 350 millimeters by 450 millimeters and 75 millimeters thick, bolted to the lower base plate.
Also note, I'll be uploading all of his videos as a playlist on my channel and so on as well, because he doesn't promote enough. He just has it as like on a random unlisted video on Odyssey, and then he embeds it in his Rich Planet, which which still gets decent views, but not that much. So only 30,000 visits, which is still pretty big for an alternative person. But again, he can get a lot more going viral, and there's no way we can get viral and so on besides searching on Google. He's doing this just to test out the claim, right? Yeah, he's doing that to see if it's real, and then but he's doing it in a very scientific method, where it's like if he can validate it, and now it's like, well, let's go. But yeah, he is I think the real deal. But then with some possible Freemasonic questions, I'll need to ask him again. If he's on the show, that'll be the first thing I ask him, like just so that we're all on the same page.
There is a mounting block made of wood. This consists of 18 millimeter thick panels arranged in a box.
You get your channel banned? No, you were not. I've uploaded some of his stuff. Again, he got his stuff because of the he had the Manchester one, and he sold the book. And you have to understand why he got legal issues. Like he actually went and was actually doing journalism and trying to interview the actual fake witnesses. I mean fake. Yeah, the fake or the alleged. He actually went and tried to interview the alleged injury person, like people that got hurt from or alleged to have gotten hurt from the Ariana Grande alleged bombing. And then he actually put a camera outside of their house, but in public, just to see if they can walk. But he intended it to be only for private, so he didn't upload it anywhere. It just it was for his own sake to analyze their injuries or not. So again, what I'm trying to say is upload his stuff. I uploaded his stuff. I uploaded the crop circles one. I uploaded his German New Medicine one. So here's one I uploaded on my MES Truth. But I will be uploading his free energy experiments and so on. So again, there is nuance to everything. They don't just go and so if you go to oldest. So this is the one here, Rich Planet Show 28. Put on MES Truth. I could have probably done it on my Math Easy one. So there's one I uploaded, and it's pretty good. This is the German New Medicine, where the show he had. Anyways, let's go back. We have 3 minutes, guys. We have 3 minutes till 12. I'm gonna go for a run. I just want to see what else he has in here. But, and then illustrate again about the magnetic field stuff. And also, I want to glue the magnets and repulsion. See what happens.
170 millimeters wide by 200 millimeters high, with an 80 millimeter section cut out to house the rotating discs. It is reinforced internally with more wooden block sections. The copper rotor or shaft is 200 millimeters in length, with sectional diameters of 20 millimeters, 25 millimeters, and 32 millimeters. The diameter near the shoulder of the 20 millimeter section has a slightly larger diameter to incorporate the press fit of the copper disc onto the shaft. There are 2 pillow block bearings made of thermoplastic with stainless steel inserts. There is one 20 millimeter bearing, which is a slip fit, and a second 25 millimeter bearing, again slip fit. The conducting disc is made of copper. It is 180 millimeters in diameter, 10 millimeters thick, with a 20...
Oh, there's a ring again. Okay, so you guys see the ring? Again, here at MES, we gotta figure out what this ring is. So if you guys know what this ring is, let me know first, or you can ask him, but don't tell him I was doing a deep dive on his ring. Let's see if it did it better. That was a previous zoom. Okay, now we can zoom in this one. Yeah, this was probably harder to see. Okay, anyways, it's harder to see. We gotta find out the ring, guys, at all costs. Gotta find out the ring. Gold signet ring. It looks like just a gold one. Okay, it's on the left hand. He's got a left other finger. He exposed a little cover up. He did what BBC did to Mob Deep. Yeah, I saw the Mob Deep. He went to ask questions. Double standard is a, yeah, is a B. Yeah, definitely. Okay, let's go back to the end machine. I just want to see some more, and then I'll. Okay, so here it is: basic copper disc and then magnet.
8mm center hole and 6 equally spaced 4.5mm through holes. The magnets are N56 neodymium. There are 2 of them, which are 176mm in diameter, 20mm thick, with a 26mm center hole, and again 6 equally spaced 4.5mm through holes. The magnets are axially magnetized, are epoxy coated, with an estimated magnetic field strength in excess of 15,000.
Okay, so you said axially magnetized. What does that mean exactly? Is that the poles are, yeah, top and bottom? Yeah, I think that's what I meant.
An estimated magnetic axially
So the 2 blocks are magnets, super strong magnets.
And again, 6 equally spaced 4.5mm through holes. The magnets are axially magnetized, are epoxy coated, with an estimated magnetic field strength in excess of 15,000 Gauss.
Oh, 15,000 Gauss. Okay, he's got super strong magnets set up there. I'm gonna go here, and he also interesting point he made is that he has much stronger magnets than Bruce Palma and those I had because of the advancements in magnetic making. So I'm gonna go right here and axially magnetized. Let's see what the image is. If there's an AI image creating thingy. Yeah, so axially magnetized, so north and south. Yeah, so basically it's the typical magnets set up here, and there's diametrically magnetized, skewed magnetized. So you can do this for rotation and so on. Multipole magnetized. Interesting. So this is how it is, like that. All right.
The drive motor is housed in an aluminium case, 240 volts, single phase, 0.75 kilowatt, and runs at 2,900 RPM with a torque rating of 2.53 Newton meters. It is an induction motor. The disc brushes are made of carbon copper alloy. There are 3 pairs, but only 2 are used currently. The surface area of each brush is 12mm by 32mm.
Yeah, so there's 3 pairs. I think it's 1, 2, 3 pairs. Oh yeah, there should be another one somewhere, but he's only using 2 right here. Anyways, so basically he puts his brush right here, copper brush wires, and then as it spins, this collects electricity. It basically collects electrons. That's all it is. Basically, they spin these both together. He like bolts these together. So I told him to do this one, which I think might be pretty big. So Richard, the key one is I told him perhaps you can attach magnets in repulsion on the copper discs. So yeah, so if you do that and see what happens. So I think definitely something will happen. I think it'll get way stronger ones. Because again, going back, so he had 15,000 Gauss, and I have these little tiny magnets, which are 5,000. This was N52, 5,000, but then I was able to get the center 8,600. So in other words, 8,000. Yeah, so almost double. Yeah, almost like 40. Yeah, I mean almost like 80% more. So in other words, so I can literally, yeah. So his 15,000 would be about like almost 30. Yeah, like 25,000 Gauss, or more than that. Yeah, so he can literally skyrocket how much strength it is. And they're all in the center. So if the magnets are like this, imagine all the Gauss would be like literally in the center, right? Like literally compressing the copper disc. So literally forcing the copper disc to squeeze out all the electrons. So I think, and I think that might be the reason why this video is the only video in the world. Like this video and the ones that
First set of experiments using 5.8 by 3.8 inch N42
using 5.8 by 3.8. Yeah. So these experiments that you're seeing right here, you're not going to find these anywhere in any university. There's no public setting that says this. I think there's someone mentioned it like somewhere when I used Grok to search for stuff. But again, you're not going to find this anywhere. And then the thing is, why in the year 2025, this is like the only video you can find about magnets and repulsion. And then and I think that's pretty much, yeah, never heard of this till MES. Yeah, definitely. So and then and again, this follows with Boyd Bushman's claims that magnets and repulsion fall slower in gravity. And then but then I think the big one, yeah, this one, but also Bruce Palma's machine, which is like also suppressed. So now it's like, now you add the actual in repulsion. Then what happens? Okay, we'll go back to the Bruce Palma's one. I thought he mentioned it in repulsion. I could have sworn he mentioned it. Repulsion. Yeah, I'm gonna go to the original. Okay, I'm gonna go to Bruce Palma. archive and go right here. Okay, guys, and we're over limit right now. I'm gonna go Bruce Bowen archive. I just want to go 2019 or something, because his old website it got shut down. Now just redirects to some other one. I want to search. I could have sworn he said repulsion somewhere. I thought I could have sworn something like that. But anyways, we'll get to it in a bit. But look how giant his was. So you get the idea, and see what Richard Hall did, and see what else he did. Jumping something that takes 72 seconds to hit the ground is crazy. You have to admit. Yeah, 72 seconds, and to compare that with the normal gravity, that'll be literally under a second. Like, because that's 6 feet 1 second. Yeah, the speed of gravity is like 32 feet per second. So it's like less than a second, and it takes that long, 72 seconds. And it's double the weight. So again, you have to keep in mind, it's double the weight of this one right here. And again, I was trying to get Andrew Johnson to like grasp it. Yeah, I was trying to get Andrew Johnson to grasp how important that was. He's like, it's just eddy currents. I'm like, hey, okay, what if? Yeah, so Andrew Johnson said it's just eddy currents and lens all. Yeah, I'm like, even then, it's still pretty amazing. But the key thing is, let's say it took 4 days to fall. So it's like, okay, okay, that's anti-gravity. Okay, I don't really care what eddy currents, lenses law, and all that. So it's like the question is, it's a quantitative thing. The key part is the quantitative, not what's actually put in a copper tube. Yeah, okay, what if it takes 400,000 years? Okay, it's still eddy currents, lenses law, but it's still absolutely magic. All right, so that's me with my. Anyways, he does this.
They are spring-loaded and mounted on 16mm nylon steel one.
Yeah, anyways, I just want to see what the results are. I didn't have time to look at it.
For the electrical power being generated, consider and no load tests. It ran at 1,000 RPM and produced...
Oh, Thomas Vallone. Interesting. I think, John Hudson definitely knows him, I think. This is Vallone. Very familiar. Okay. And here's what's the...
Professor of... My point with the experimental lab homopolar machines in these two examples, which put out a staggering 25 watts and 10 watts, aren't really capable of showing conclusively whether the effect exists, because the instrumentation error constitutes a large chunk of the measurable output. Now, my machine, however, due to the incredibly strong magnets, can produce 80 watts and 170 amps. This represents over 10% of the input power, therefore an effect, if it is there, should be easier to observe.
Okay, so he hasn't concluded yet. So we will get to that anyways. But again, he's doing the hand thingy, and he got a weird ring. So anyways, if you're watching Richard Hall, no offense, I need to be consistent. So if there's one thing you guys have to grasp with me, I literally don't care who a person is. If truth is truth is truth is truth, boo boo. All right, let's go. I'm gonna. Have you not seen Rafki? R.I.P. No, what happened to Rafki? Rafki. What happened to Rafki? Oh no. Okay, this is the AI bot. Did he die? No. 1 second, guys. I'm trying to figure out what in the world's going on here. Did they take out Rafki? Rafiki. No threads. My shorts blog. Rafiki. Okay, I need to find out what happened. Okay, I'm gonna ask this guy what happened. Okay. What happened to him? Noah. What happened to our AI bot? My goodness, did somebody take him out? So okay, guys, that's all for me. I'm done, and I'll watch the full show later. I haven't seen it, but anyways, pretty epic stuff. And if you guys know what the ring is, let me know. If you can ask him, don't mention me. Okay, it's still going. Blue face, oval, knight or horse. Personal family emblem, possibly historical. Gold colored. Detailed analysis, oval ring. Okay, is there any Freemason? Okay, doesn't say any Freemason stuff. Okay, so at least Grok AI is covering it. But anyways, guys, let me know what that ring is. Find that ring. I'll send a link to that ring. Yeah, you guys find that ring. Okay, and anyways, and Ashton Forbes. But yeah, so Richard Hall is still pretty... Oh, no sound for me. Is this good now? Oh, it's going back on. Okay, there it is. Oh, I completely forgot about the chat. All right, let's go, guys. This is a Rumble chat. All right, thanks for watching. Great day. I'll open up. Yeah, I think I'll do that next time. I completely forgot the Rumble chat because I checked before and it wasn't anything. Anyway, guys, never forget 9/11 Moonchild. Heard it here first. Let's go. Bless up, John. Bless up, man in chat. And I'm gonna head out, guys. And yeah, John and gang, find the ring guys. Right, guys? F Forbes. Yeah, Forbes is again Forbes. And that meme I made, I avoided putting in Bob Greener again strictly because he covers he knows about 9/11 and he covers the Hutchinson effect and John, so he's part of the John Hutchinson crew. So I didn't include Bob Greener there. So again, hopefully Bob Greener just get away from this Ashton Forbes. He's like a black hole, a wormhole of nonsense. All right, guys. Anyways, that's all. I'm gonna go close some stuff. Where did I go? Okay, I lost the thingy, so I need to find it. Okay, I need to click this one and then analytics. Not analytics. This one. Whoops, wrong thingy. Live. Bob says he talks to John every day. Yeah, yeah, definitely. That's great. I just get a million messages from John, and I'm trying to like help him. Okay, I'm gonna end the stream. Guys, ending the stream in 3, 2, 1, and I'll put this right here. Oh, thanks for watching. Have a great day, and end stream, guys. And anyways, create some free energy, anti-gravity, and so on. Have a good one. Ciao. All right.